Hello my dear students, today we are going to talk about solutions. So as you understand, we are starting a new subject, we are starting a new unit. So in this unit, we will be on Module H, Unit 5, Lesson 1, okay? We will be on the pages 266 and 274. So there's a lot of things to learn about solutions, but don't worry because it's a really easy and enjoying subject that I hope that you will just understand it quickly and easily. So if you are ready, we are starting to the solutions. So if you opened your books from your online access, you may see there in the first page they are giving an example about glass in solutions, but I will give you even an easier example. If you are putting sugar in your tea or in your coffee, and when you stir it, you will see that the particles of sugar will dissolve in the liquid. So this is what we call as solution. We are expecting solution when we mix two things. A solution will give us a homogeneous appearance. Okay, we can't separate the substances inside a solution. That's why we call them as solutions. Basically, they are mixtures. In solutions, we are mixing two different ingredients. Okay, but we can separate these ingredients visually. So we can identify the different parts by looking at them. Okay? And a solution can be solid, liquid, or gas. It is important. You can see some solid solutions. You can see gas solutions, you can observe gas solutions, and you can observe liquid solutions. So like in which is very important in gas and liquid solutions, light will pass through, so they are basically transparent. Okay, so if a mixture is transparent, if you can't see the particles inside this mixture, if it's a liquid or gas, so you can say that it is a solution. Okay, they are so small, these particles will be so small, it is not a chemical reaction. The identity of these two different materials will not change when they go inside a solution, like sugar and water, but because sugar particles will dissolve into so small particles, you will not be able to separate them with a filter. So I really like this example because it is just summarizing everything we can imagine about solutions. This bronze statue is an example of a solid solution. Bronze, but we are using bronze in most of the time in statues, and it's an example of a solid solution. Okay, the air surrounding this guy here is a gas solution, but we are breathing. Remember our topic related with atmosphere. We say that we have different types of gases inside the air, but we cannot separate them. We can't see or observe them individually. So this makes air a solution, okay? And this is the most famous gas solutions that you will hear for this topic, okay? Don't forget, the air is a solution. And salt water in the ocean or in the sea that he is looking at is a liquid solution. If you were able to go nearby a sea or a salty lake or an ocean, you will probably you had a chance to just look at this water. you will not see the salt particles inside the water because it's a solution. It is impossible to differentiate them just by looking at it, okay? But if you drink it, you will feel the taste of salt. So you will know that there is salt inside of that water. Or same example, like when you just mix water and sugar or water and salt at your kitchen. Try it. You will not be able to see the salt particles or sugar particles inside the water, but you know that sugar or salt are keeping their identity, because when you drink this, you will see that the taste of salt is still there. So salt is still inside that water, but it is just dissolving into small, really small particles. So that can be surprising, because still is also a solution. Okay, it's called as a solid solution. It is formed from iron and carbon. You can use still as an example for solutions also. What else we have? The alcohol that you are using as medicine, as cleaning the wounds, is a solution of alcohol and water. The vinegar is a solution of acetic acid and water again. It is called as also fruit acid. It is found inside the lemon most of the time, or these type of fruits. So what else we have? Soda. I like this example a lot. Or Coke. So you may not imagine that something you drink can be a solution of liquid and gas, but remember these gas particles when you open a bottle of Coke? So this is basically the gas dissolved inside this liquid. So it is a solution of carbon dioxide, which is a gas, and the liquid that is the soda is made up of, or the Coke is made up of. Okay, and we have another metal called as brass. It's also a form of solution. But the thing is, we can't call every mixture as a solution. We have some mixtures that may confuse us, that we can think that they are also solutions, but we should separate these from the solutions. Okay, the first thing that you should remember about solutions are particles in a solution are really small. That's why solution is looking unified, homogeneous, and they are looking transparent. Okay, the light can pass through these type of materials. For example, in this solution, in this flavored drink, this is called as a solution. Okay, but milk, on the other hand, even though we can't see the particles inside that milk, it is not a solution because they are larger. We call this a colloid, and the particles are still larger than the particles in a solution, and they can scatter light. They are not looking unified. They are not looking transparent. In milk, we can't see, we can provide a transparent vision, right? But still, it is a homogeneous mixture. It is looking unified. Or what we have as gelatin. It is also a colloid. It is a colloid in solid form. So we can't say that all colloids should be like milk. We also have like gelatin or fog. You know fog? Remember fog? We can't see the particles inside the fog. It is not like exactly like air. That's why we call them as colloids, not solutions. What else we have? Here we have also tomato juice. So tomato juice is neither solution nor a colloid. it's a suspension. So in suspension, the particles are really large enough to be seen, and it is not transparent most of the time, and we can see that they have larger particles inside this mixture. So they are different than the colloids also, and we can sometimes even we can just separate these particles with a filter paper, like for example in this suspension they can be separated physically from the liquid. Here probably it is a suspension of sand and water mixture. Or what else we have as an example? Let's see. A snow globe, for example. We can see the particles in a snow globe, and this is called as a suspension because we can separate the particles. Okay, I have an example from your book actually. So we have these representations of particles, let's say, and it is asking us which of them is a colloid, which of them is a solution, and which is a suspension. You have this, the answer of this question in these slides, but still I want to solve this with you. So what we said, that in solutions the particles are so small and so they are unified, and also in colloids the particles are unified, but they are bigger than solutions. So when we compare these two, we can understand this is a solution and this is a colloid. On the other hand, in suspension we have really big observable particles inside this liquid or gas. So we have these huge particles, so we can say that this is basically a suspension. So the solution can be a lemonade, colloid can be a milk or cream, and suspension can be a mixture of flour and water. So I guess we are all clear about the differences between solution and other types of mixtures. So let's move on. Another important but really easy thing about solutions is the parts of the solutions. We have two parts, solute and the solvent. Solute is the substance that is being dissolved. For example, the solute can be the sugar inside the tea. Okay? On the other hand, solvent is the substance which is doing the dissolving. Okay? Solvent again can be a liquid, gas, or solid. For example, with the tea example, the solvent is the tea. Let's also write these examples here. So tea will be the solvent and sugar will be the solute. Water actually the most common liquid solvent. It has a really high property for being a solvent, really strong property. And when a solution forms, of course, solute particles will evenly distributed into solvent, and we will not be able to distinguish between the solute and the solvent, don't forget. Here we have an example. You can pause the video and try to solve this example by yourself first, then you can look at my answer. We have some different types of solutions: air, carbonated water, salt water, and bronze. And it is giving us the solutes and the solvents. For example, in air we have oxygen as solute because it has the lower concentration, and nitrogen as solvent. So state of solute should be what? Gas, of course. And carbonated water in carbon dioxide and gas. And state of the solute, solvent is basically liquid. How about salt water? State of the solute is solid, and state of the solvent, which is water, liquid. or in bronze we say that this is a solid solution. State of the solute is solid and state of the solvent again solid. Okay, you can use these examples as examples for solution, and this table will help you to differentiate the solute and the solvent. So what else? We need to learn about concentration when we are talking about solutions, which is a really important thing. Concentration basically calculated by this formula. If you are trying to understand the concentration of a solution, you are dividing mass of a solute to the volume of the solvent. That's why it is expressed as grams per milliliter, which is gram is the unit of mass and milliliter is the unit of volume. Okay, so if you are asked for the concentration of a solution, you will use this formula. Okay, you will just divide the mass of the solute by the volume of the solvent. So what is concentration? If I just dissolve small amount of substance into water, it is called as dilute solution. Okay, if I have small amount of solute in a given given volume of solvent, it is called as dilute solution. So if something has low concentration, the solution called as dilute solution. Okay, so and like it is saying here, at low concentration the solute will dissolve completely inside the solvent. Okay, so if I want to increase the concentration, what should I do? I should add more. Okay, so when I increase the concentration, I will have a concentrated solution. Okay, it is when there's large amount of solute, like large amount of sugar, solute dissolved in given amount of water. Okay, in same amount of water, if I am just dissolving more material, more substance, then I will have a concentrated solution. Okay, so we have the same amount of liquid here. See, so in dilute solution we have less amount of solute. In concentrated solution we have more amount of solute. In saturated solutions we have a lot of most solute that can be completely dissolved inside this solvent. Okay, this is the highest amount that this amount of solvent can dissolve. Okay, let's check from here also. So when I'm increasing the concentration, I am increasing the solute. Okay, I am adding more sugar here, and for saturated solution I will have the highest amount and it will not dissolve any more solute. Okay, this will be the highest amount of solution. So also we have something called as supersaturated. What can it be? I can force this water to dissolve more sugar by heating it, for example. If I heat it, I will increase the capacity for dissolution, and I will be able to add more solute, more sugar, for example, and this will change the concentration of this liquid, this solution. Okay, normally it will not hold that much solute, but because I am forcing it by changing the temperature most of the time, it has become supersaturated. But even the smallest change can disturb this solution, and the supersaturated solution can not hold the excess solute and they will just precipitate, like you see here. Okay, so this is what we call as supersaturation. And you will see another example here if you check your notes, also from your PDF. And so we learned what is solute, okay, what is solvent, and what is dilute solution, what is concentrated solution, and what is saturated solution. Now we will learn something called as solubility. So solubility is the ability to dissolve in a given amount of solvent at a certain temperature and pressure. Okay, we can measure the solubility of a solute. For example, we can measure the solubility of water in given amount of temperature and pressure, how much sugar that 100 milliliter water can dissolve, for example. So it can be just changed by temperature for solid solutes. Okay, if we are trying to dissolve solids like sugar, we can increase the temperature and it will cause greater amount of solute can be dissolved. Okay, but if we are trying to, this is important and you are using it every day actually, if you are trying to dissolve a gas inside a liquid, you should decrease the temperature, not increase. You should keep it cold. That's why we are keeping our Coke or soda inside the refrigerator, because we don't want them to lose their gas. We want to keep the solution as it is. And also we are keeping it closed because we want to keep the pressure inside stable, because also we need a certain pressure in order to dissolve the gas inside the liquid. Okay, soda example is a really good example for solution of gases. On the other hand, you are increasing the temperature for tea or coffee in order to dissolve more sugar. So temperature for solids, it will when they increase, it will increase the solubility. Okay, and also we have something as surface area. So imagine that you are putting a sugar cube and also you are putting a grained sugar in 2 different cups of tea. So sugar cube will dissolve slower. It will take more time because the particle, the surface area is higher in there. But when we decrease the surface area, when we use grained sugar, we are increasing the surface area and we are just increasing the solubility. And one easy trick also, when you stir this tea with your teaspoon, basically you are increasing the solubility, increasing the solution rate, right? So it is also affected by the stirring or shaking. So I said that solutions are easy because we are using solutions in our everyday life. They are really similar for us and we can give really good examples for solutions from our kitchen. So please try to just try these mixtures, try these solutions, and try to find the effects of temperature or surface area and stirring into the solution rate, into solubility, and you will see that it is really easy to experiment. So let's just solve this question in order to make it more clear. So we will sort these pictures into these categories. Is it decreasing the solubility or increasing the solubility? So if you want, you can pause the video and try to solve it by yourself, then just use my answers. So if I increase the surface area, what we say that we are increasing the solution rate, we are increasing the solubility. If we stir something, if we stir our tea with teaspoon, we are increasing the solubility again. Lower pressure. So imagine, what does it mean, lower pressure? When you open the bottle of Coke, you are lowering the pressure inside. So is it decreasing or increasing the solubility? Will you lose the gas inside this liquid? Yes. When you lower the pressure, you will lose the gas. So it is decreasing the solubility. Or lower the surface area. This guy is using sugar cubes. It is decreasing solubility. Lowering the temperatures. If the sugar will dissolve slower in a cold tea than a hot tea, so increasing temperature will increase the solubility. So what we learned in this session, we learned what the solutions are. Solutions are homogeneous mixtures that are made up of two or more substances, like the tea and sugar. Solutions can be liquid, gas, or solid. Bronze, we gave bronze and steel as solid solutions. Air is a gas solution, and for liquid solution you can just give example for the sugar tea solution, the lemonade, or the seawater, the salty water basically. We have something called as solute and solvent. We have something called as solubility, and we learned about the concentration of the solution, don't forget. And we learned different concentrations like dilute solution, concentrated solution, and saturated solution. Okay, so solutions, like I said, it is a long subject, but it is a really easy, simple subject. So please try to just cover all this, what we learned from your book also. You can find this topic in Unit 5, Lesson 1, pages between 266 and 274. Okay, thank you for listening. Let's see you in the next session.